Nevada Virtual Academy, we are back. Algebra 1 is moving on successfully, hopefully, right? Semester 2 functions. And the first question is, what is a function? Okay, we talked about in class, let's remember, um, if you have a relation in which each input will have only one output, that relation can be called a function. Okay, in other words, imagine that you have your function, right? And your function is like I don't know, like a box. This is my f of x. Okay, well, whatever you put inside this box, and usually we have the x for it, right? And obviously for this case, x will make your inputs, right? Inputs. You put it inside the box, and this obviously together, all the x's will make your domain. Whatever you take outside of the box after that f of x magic trick will be done, will be applied to all your x's, and this will be your y's, right? The outputs. And this will make your range. In order for this magic box trick to be a function, you need to keep in mind that for the same x that is put inside, you will have always the same output, the same y, right? And you may have the same output for two different x's. It doesn't matter. As long as if you take the same x, you put it inside, and always the output will be the same, you will have a function. Think about the magic hat, right? You're the magician. If you put a white rabbit, whatever you pull out of the hat, let's say a pink elephant, will always be the output for your white rabbit. You drop the white rabbit in the hat, you pull out a pink elephant, the same pink elephant all the time. Alright? And you will see, and you are able to see, you were hopefully, checking your manual. Here you have the example with the people's height, right? No person can have more than one height. And here we have to, add in parentheses that we're talking about the same time, the same point in time, because as we know, especially for your group age, you guys will definitely have a different height in a different time. And maybe the same person, let's say John, well, John is a 14 years old now, well, 1 year later, John may be taller than it is today. But we're talking about the same height for the same person using the same point in time. Okay, so nobody can have two heights. I mean, right now, if I'm checking your heights, every one of you will have the same height for that hour, let's say, right? Okay, and in class we talked about other examples, ways to determine, and as you can see here in your manual, right, I'm checking my x's, and x equals 2, the output is -9. I have a gain 2, and the output is -7, right? Well, I can say that this relation is not a function right away. Okay, why am I saying that? Is because for the same value, for the same input x2, and you can see another example here, my output is different. This is a relation, but it's definitely not a function, because for the same 2, I can get different values, right? Alright. Okay, let's try, oh, by the way, in class we mentioned also the vertical line test, which asks you to draw a vertical line at various, for various values of your of your x, well, or this will definitely give you different values for your x. As you can see, whatever my vertical line intersects my x-axis is telling me what x I'm using. And if your line crosses your graph, your function's graph, in only one point, then that's a function. Okay? If you have more than one point in which your graph is crossed by your vertical line, then that relation is not a function. You can see in this example here, B, if I'm going through this point, my vertical line crosses my, the graphical representation of my relation in more than 2 points. This is not a function. Okay? Let's see a few problems from your manual. Right? We did some problems in class today. Okay. Scrolling down. Okay. Here we are. How about problem number 1? We need to determine if this is a function. And first thing what you have to check is your x. Okay? X is 3, 0, -2, and 3. Alright? If no x repeats, that's a function. Well, in this case, we have 3 and 3. So we have 3 as an input repeating twice. Okay? And the next step for you will be to check if you have the same value for that input. Only this you have to check, right? Only these two pairs, because everything else has different inputs, which is fine with me. Most likely will be a function, unless for the same input here, 3, I'm getting different outputs. And as you guys can see, I have 3 input, 2 output in the first pair, and in the second one I have 3 as an input, -2 as an output. This is not a function. Okay, let's check number 2. X 7, -3, -1, 9, -4. Function. How do I know that? Well, x does not repeat. Okay, so for whatever I have in here, all my inputs are different. This is a function. How about number 3? I got 14, 15, 12, -2. Function. No x repeats in here, right? Number 4. -2, 4, 3, 6, 4. Hold on, I have a 4 that repeats. If I don't have the same output, it's not a function. As you can see, for 4 as an input, I have 5 as an output, or -4. Not a function. Okay, let's check number 7. I have a t-table here. X -8, -2, -2. Okay, so -2 repeats. 6 and 8. I only need to check the output of -2. If it's not the same, and it's not, right, this is not a function. Okay, now for the type of problems like number 9 and let's say 10 in here, right, you're going to use the vertical line test. Crosses my graph in one point. I'm using another vertical, another vertical, another vertical. As you guys can see, there's only one point of intersection. This is a function. Can you tell me what function is this one? What do you notice? You have a line that's parallel to the x-axis, which means the y for these points, for every one of these points, will always be the same, and this is a function with the equation y equals -3. Okay. How about number 10? And I will switch to green. Number 10, we have a graph. I'm going to use the vertical line test. Well, the first vertical line crosses my graph in 2 points. This is not a function. Okay. How about number 11? Same story. And you notice that if you go to these 2 points here, to the -6, you draw a vertical line to the -6 that crosses through, through two different points. This is not a function. Alright, and so on with all the others. Let's see a different type of problems. Okay. 21-25. Choose the graph that best represents each situation. Number 21, let's see. A student taking a survey asked the first 10 people in line in the cafeteria how many people are in their family. Okay, so we need 10 points, right? Because this student taking the survey deals with 10 people in line, right? So you check A and B. Do you have 10 people? 10 points. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. In the first one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. In the second one, right? However, on the second one, because of these lines here, you can actually have more than 10, than 10 persons, or more than 10 data points, because for each one of these lines, segments between your points, you can imply there will be another answer, right? However, keeping in mind that obviously you cannot have 0 people, you cannot have 4.5 people in line, right? Should help you to decide that, what, for this situation here, what my student is asking 10 people in line, right? He's asking the first person, the second person, the third person, fourth, fifth, sixth, seventh, eighth, ninth, 10, right? Graph A will be the best representing that situation, all right? Because I only have the people, the person, right, and the number of members in its family, in his family, her family, and I cannot have a graph like this one that is represented B, because this implies some intermediate values between 7 and 8, 8 and 9, 1 and 2, and so on. All right, and that's why I would choose A as the best answer. All right, how about problem number 28? Okay, Tia's math teacher gives quizzes several times a week. Tia's scores continue to improve all year, and we can see that on the graph. On the scores that she gets for every one of the quiz, and you can see that the scores are going up, right? Quiz number 50, she's got the high score compared to the first quiz number 5, right, which had a score of 60. Use the graph to estimate Tia's score on the 27th quiz. How can we do that? So let's start with A, right? Part A. How can you find that out? Well, quiz 27 is right here between quiz 20 and 25, on 25th, right? The 20th and the 25th. I mean, hold on, what am I talking about? It's between 25th and the 30th, right? So your 27 is, almost halfway between those two. That's the 27. In order to estimate what could be the score for that, knowing that we have, a positive slope kind of graph, right? Wherever this vertical line from where your 27 is intersects this a line here, well, more like, segments connecting the, the results for Tia's quizzes, this will be a good approximation of her score, right? As you can see, that's approximately what? 75% on the 27th quiz. That's most likely 75, 76, or 74, but close to the 75%. Okay. How about B? Assuming that Tia's scores continues to improve at a rate equivalent to her previous average rate of improvement, estimate how many total quizzes she is likely to take before her score reaches 100%. Alright? How can we find that? How can we approximate that? Well, there are many ways. You can use your graph here, right? And if your graph will follow the same slope, right? Because if you guys can see here, we can approximate this line of TS score improvement, and later on we're going to talk about the line of best fit. By drawing a line will be the closest one to every one of these points, right, that we have on the graph. So basically we need a line that will go as close as possible to all of these points, right? And that would be the line of best fit. And whenever this line will cross, the horizontal line from the 100%, okay, so you have a point in there. Let's use red for it. I said red, but I have blue. Hold on, okay. Red. This is the line that will, most likely approximate the point in time where Tia score will reach 100%, if will ever happen, right? To find, what quiz number is that point in time. Hold on. Okay, you need to drop an horizontal line, a perpendicular line to the x-axis, and by extending your x-axis there, and this is the approach of by using your graph, you can approximate maybe you can approximate the number of quiz of what would be the total number of quizzes when Tia will be able to reach that point. And as you can see, each one of these units that we're using here, right, as our scale, is basically 5 quizzes. 5 quizzes, 5, 5, right? This was the 50, so it's going to be the 55th, right? This is going to be the 60th, and this is going to be the 65th. Right? And the answer to B would be that most likely when Tia approaches or is around to take her 65th quiz, she could be close, right, to reaching the 100% score. Make sense? Like I said, in the future lesson we'll use an algebraic approach and not the graphical one to calculate when it is most likely the point in time. Well, she will have 100% following all the data that is given to us. Okay? Good. How about problem number 30? Emilio earns a percent commission on his sales at the car dealership plus a fixed bonus on all weekly sales totals of at least 10,000, right? So he needs to, in order to get a fixed bonus, Emilio needs to sell at least $10,000, and everything over that will, award him the commission. I'm talking about bonus, right? The graph shows possible commissions for sales totals of 10,000 to 100,000. All right. Part A. Use the graph to estimate Emilio's commission if his sales total is $35,000. All right. And we have a graph that we definitely need to use. And because already on the graph, we have represented Emilio's commission in terms, or in relation to his sales, we can just go on the graph and first look for the sale total of 35,000. 35,000 is right here between 30 and 40, right? Next step will be for you to draw a vertical line to the $35,000, right? Whatever that graph crosses, intersects your graph, you will need to construct an horizontal line that will intersect your y-axis, which represents the commission, right? And as you can see, in this case, it's between 1,050 and 1,200, right? Most likely halfway between that, and that's what you need to find, right? What is halfway between 1,050 and 1,200? There are a few ways. First, you can find what is the difference between 1,200 and 1,050, and you have what? 150. You're going to break that in half. That will give you 75, which you will add to your 1,050 plus 75, right? That gives you what? 1,000. Well, let's go right to left, right? 5 plus 0, 5. 7 plus 5, what? 12. 1. So you have $1,125. That most likely would be Emilio's commission. That's one way. Another way, what I said, would be just to find the average. The average halfway between 1,200 and 1,050 by adding them up and dividing them by 2. Okay, so you don't have to do subtraction and then addition. You just go one addition and then you break it in half. What is that? 1,200 plus 1,050 gives you 2,250. Am I right? Divide that by 2 and definitely you will have the same answer. You should get the same answer. 1,125. Alright, part B. So we're done with part A. Part B. If the fixed bonus is $50, right? Fixed bonus is $50. What percent is Emilio's commission? How can we find that? An easy way to find that would be to check any one of these points that are given on your graph, and find first what is the commission for that, right? As you can see, if I'm going for $20,000 here, right, the commission is most likely $650. However, we know that $50 for 650 represents the bonus. So basically, Emilio's earns a percent commission for the $20,000, right? Of what? Of $600. Okay. So for 20,000, he gets $600. If I'm going down to, 10,000 cells, right? 10,000 cells. He's getting what? 350 approximately. So for 10,000, he's getting 350, taking out the $50 bonus, right? I will get a commission of 300. And if I'm going, to a higher value, let's say $30,000 sale, he's getting a commission of what? 950, right? That's 950 right there. If you take the $50 out, will be 900. So it looks like for the 30,000, he gets a $900 commission. I'm going higher to 40,000. And what you guys notice, 10,000 to 20,000 is making 300. 20,000 to 30,000 is making 300 more. So it looks like for every $10,000, he's getting $300 commission. All right, that seems to be the average. To find the percent of that, what are you going to do? You will divide apart the 300, right, by the whole amount, which is 10,000. Now obviously we can simplify here by 10 by 100, right? And looks like you have 3 over 100, which we know that represents what percent? 3 per 100, 3%, 3%. And that's the answer. All right. For part B here, I should erase this part, right? The answer to that question, if the fixed bonus is $50, what percent is Emilio's commission? Emilio's commission is 3%. Okay, and we're done with this problem. All right, this is it. Tomorrow we'll talk about functions and functions equations. Okay, let me know if you have any questions. This is it for now.